All right, let's solve number 64 by completing the square as per the directions. So we've been given a squared minus 6a minus 16 equals 0. And the first part or step in completing the square is to move the constant. So we'll be left with a squared minus 6a, and we're going to leave a little space here, equals 16. And now to complete the square, we're going to take half the middle term. So the middle term here is negative 6. So half of negative 6 is negative 3. And then we're going to square it. And we're going to add the result to both sides. So negative 3 squared is 9. So we're going to add that result to both sides. And now that we've completed the square here on the left, we can write this perfect square trinomial as a perfect square binomial. And the way that we do that is open parentheses, whatever variable you're working with, take half the middle term again, close parentheses, and then squared equals, and now 16 plus 9 gives us 25. We want to solve for a, but right now a is kind of trapped inside these parentheses and raised to the second power. So first things first, let's go ahead and get rid of this second power, and we know that we can do that by taking the square root of both sides. But when we create our own square root here on the right, we have to take the plus and minus, positive and negative. Here on the left, the squares kind of go away. We're left with a minus 3 equals plus and minus. Well, what's radical 25? Just 5. And finally, solving for a here, we'll add 3 to both sides. And that's going to leave us with a equals 3 plus 5, which is 8. And a equals 3 minus 5, which is negative 2. So a equals negative 2 and 8. Again, remember, the reason we have two solutions is because when we took the square root of both sides, we have a plus and minus. So we create two answers at this step. So we have 3 plus 5, 3 minus 5, hence our two answers. And again, if you wanted to check yourself on your final exam, take each of these solutions, negative 2, plug it in to the left side, you should get 0. Take 8, plug it into the left side, and you should get 0. And if you did that here, you would see that both of these solutions are correct.